What's the difference between encoder and decoder architectures in transformers? Encoders and decoders are two key components of transformer architectures designed for different types of tasks. So let's break down the differences. In the encoder architecture used for understanding text, yeah. So what's the primary role of it? It processes and understands the input text. The main use case for it is natural language understanding (NLU) task. Example models are BERT, Roberta, Disselbert. How it works basically? So it processes the entire input at once, that too bidirectionally, converts words into contextualized embeddings, word representations that capture meaning based on surrounding words. Outputs a rich representation of the input, which can be used for classification, search, or other understanding tasks. So, what are the key features of it? It's one, bidirectional, that is, reads text from both left and right to understand the full context. And what's the task it can perform? So, sentiment analysis, named entity recognition, and question answering without generation. Encoder is like a reader who carefully analyzes the text but doesn't write anything new. What's a decoder architecture, which is used for generating text? So, what's the primary role of that? It generates new text step by step based on input. So, the main use case is for natural language generation, NLG task. Yeah. So, what are the example models for that? Like GPT-3, GPT-4, Llama. How it works? So it takes input tokens or previous generated words and predicts the next word. Okay. It uses self-attention and auto-regressive decoding to ensure fluent text generation. The outputs generated text, producing one token at a time in a sequential manner. So what are the key features of that? It is auto-regressive, that is, it generates words one by one, predicting the next word based on previous one. Good for tasks like chatbots, story generation, and code generation. So you can consider decoder like a writer who creates new sentences considering previous written words. We also have something called encoder decoder architecture like sequence to sequence, which is best for transforming the text. So primary role, it converts input text into different output format like translation, summarization, etc. So the use case is basically for text transformation task like sequence to sequence. The models are like T5, BART, MT5. So how it works? The encoder processes and understands the input text. The decoder generates the transformed output, that is translated text or summary. Now this enables tasks like machine translation, English to French, or text summarization. So key features are like it uses both encoder and decoder, okay, best for tasks that need both understanding and generation. Good for tasks like summarization, translation, paraphrasing. So we can consider encoder decoder model is like a translator who reads a sentence in one language and writes in another language. So this is a comparison table that you can see in terms of feature like direction, purpose, input, output. Okay, what's the best use case for this model? Okay, and then example models which are given there. Thank you.